This video is based on an IEEE wireless communication paper entitled Characteristics of Mobile YouTube Traffic, done by a team at the University of Granada. This was published in the year 2014, Volume 21, Issue 1, page 18 to 25. Hi there! If you're watching this video on YouTube, then you're amongst 1 billion users that YouTube has. And this video is one of the 4 billion videos that will be viewed today. This makes YouTube the leading source of traffic in fixed and mobile access networks in the world. While there are publications that characterized and analyzed YouTube's traffic when accessed from personal computers connected to wired networks and mobile terminals connected to Wi-Fi networks, there were none for accesses from mobile networks. This was why a team from the University of Granada decided to take on the tasks of analyzing, determining, and describing the characteristics of YouTube traffic in 3G mobile networks. First, let us see what happens to a video when it is uploaded to YouTube. A unique identifier, also known as a video ID, will be assigned to it. Then, the audio and video contents will be encoded using various algorithms. The encoded streams will then be encapsulated in a container file. The combination of the encoding algorithm, video resolution, and type of container defines the video format, which is labeled with a parameter named iType. Now let us see what happens when you click to watch a video on YouTube. YouTube employs a mechanism called the progressive download technique. There are 2 phases in the technique. First, the initial burst phase. This is when a significant amount of data is injected into the player's buffer. This ensures that you will have something to watch while the rest of the video is being transmitted over. Then, it is followed by the throttling phase, where YouTube servers send blocks of 64 kilobytes of data until the rest of the video has been successfully received by the client's player. The download process depends on the type of device and network connection. Now, we will take a look at the findings for accesses from mobile terminals with 3G mobile network connections. The categories of mobile terminals used in the experiment were high-end Android terminals, mid-range Android terminals, and high-end iOS terminals. High-end Android terminals employ a dual threshold policy. This is how it works. When a segment of video that is being transferred to the player's buffer amounts to 100 to 110 seconds of video time, which is also known as the upper threshold, the client will abort the TCP connection. When that segment of video is left with 30 to 40 seconds of video time, another TCP connection will be established to request for the next segment of video time via HTTP range request message. In each TCP connection, the progressive download technique is being employed. Having such a strategy avoids wasting data if the user will not watch the entire video. Mid-range Android terminals download video clips in a single segment using the progressive download technique, with the TCP receive window further throttling the download if the player buffer is filled up. High-range iOS terminals employ the same strategy as PCs connected to wired networks, where the progressive download takes place over one TCP connection. Here are some additional findings. Mobile accesses predominantly use iTags 36 and 17 video formats, which have lower encoding rates than iTags 34 and 18. Mobile accesses have on average 34 seconds of video time injected into the player's buffer during the initial burst phase, while accesses through PC with wired connections have an average of 40 seconds of video time injected. What then is the value in understanding the characteristics of mobile YouTube traffic? With YouTube being the leading source of network traffic, understanding the characteristics of its mobile traffic can be useful for designing network algorithms or functionalities that optimize the transport of this traffic. It can also aid in network planning and dimensioning with estimations of the video clips, encoding rates, and data volume. And of course, it can help to optimize streaming strategies employed by YouTube so that you can watch high-quality videos with optimal streaming speed, anytime, anywhere. This project is done by Benjie, Francis Patrick, Gehan, Kavan, Keith, and Ting. Thanks for watching.
Created using Powtoon.